Problem 5-63. Sketch the graph of y plus 3 is equal to 2 raised to the power of x. So we've got several questions that come from graphing this. So before we can graph it, we're going to have to end up isolating our y here. So let's think about that. If I wanted to do y plus 3 is equal to 2 to the power of x, I'm going to subtract my 3 from each side first. And I get y is equal to 2 to the power of x minus 3. Now we could create a table here and do our graphing here. I'm going to go ahead and come up with my points using my graphing calculator. So I'm going to go in here, I'm going to go to y equals. I'm going to go ahead and type in my function. I'm going to say 2 raised to the power of x minus 3. I'm going to graph it. So I can see I've got an exponential curve here that's going up. So I've got exponential growth. And to come up with some points to plot here on my coordinate plane on the left, I'm going to go into my table, come up with some good points here. So it says -11, -3 would be a good one. So let's do that. Let's create our own little table here. So I got the point -11, -3. You could say -1, -2.5 if you wanted to, or 0, -2. I'm going to include both of those. Oh yeah, there's plenty of points on there for us now. We've got 1, -1. We've got 2, 1. And 3, 5. Let's go ahead and plot some of these on here. I'm going to change my color to blue so we can see them. So -11, -3. Probably back about right somewhere back here. And then we've got -1, -2.5. So we're going to go back 1 and then down 1, 2.5. Then 0, -2. 1, -1. We've got 2, 1. Then 3, 1, 2, 3, 4, 5. And if we wanted to, we could say 4, 13, which would be somewhere up here. So you can kind of see how it's going to be growing here. I'm going to try to do a good job sketching it here. So over here, we're going to have our curve. Not too bad. I'm happy with that. We'll take it. So we got our exponential curve there. So we got that. Just came up with our points, came up with our equation. And now let's answer the questions. What are the domain and range of this function? So let's talk about what are all the possible domain values. As you see here, it goes to the left forever this direction, and it's curving up, but it's still going to the right. So for our domain, we're going to be saying this is going to be all real numbers. So -infinity is less than x, which is less than infinity. I remember that is the same thing as saying all real numbers. Our range for our function here Well, it's going up forever, so there's no boundary point at the top, but as you come down here, we go past -2, and then we go lower, and we get closer. Now I put a point at -3 there, but that's because, you know, we have, if you think about it, if we put in 0 for our x, we had 0, or 2 to the 0 power was 1 minus 3 was -2. Then if we went below 0, let's say -1, we ended up with -2.5. If I put in another value like -3 here, actually maybe I should pull out my calculator to show this. Actually, let's quit out. Let's do 2 to the -11th power. When we hit enter here, you're going to see that we've got 4.88 yada 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 there, so it's kind of going back here. But if we take this and then we subtract 3 from it, you see we have -2.9995, because what's going to happen here is we're never going to actually be able to hit -3. I just chose that point because the calculator rounded it there, but we're always going to end up being greater than our -3 value there. So even though I know I wrote that point there, I probably should emphasize that when I did it there, we're never actually going to hit -3. So our range should end up being y is greater than -3, because we can never actually hit -3. Maybe I should emphasize that here, that this was rounded. Not actually -3. So I don't want to confuse people there. So that's really actually -2.9999, but if you're trying to come up with a graph, pretty much you're looking at it's about -3 when you're going up that way. It will never drop beneath there. Now that would be our answers for A. B, does this function have a line of symmetry? If so, what is it? While this is going to be exponential growth, this is not going to have a line of symmetry here. So we can just go ahead and say no. There is no line of symmetry. Let's move that out of the way. Letter C. What are the x and y intercepts? Well, we can see right here that our y-intercept is 0, -2. So let's go ahead and list that one here. But our x-intercept, we have to see here, looks like it's somewhere right up in here. We know it's going to be between 1 and 2. Right, so we know it's going to be between each of those here. So how can we figure that out? Well, let's pull that calculator back out here. And remember that every point on this line right here has the same y coordinate, right? This is the line y equals 0. So what I'm going to do here is I'm going to take that here. I've got my function y is equal to 2 to the power of x minus 3. I'm going to go in and I'm going to graph that second function of y equals 0, and then I'm going to graph it. So if I want to know exactly what this point is, I am going to take that and treat it like it's a system of equations there, graphed it, and now I'm going to find the intersection point. So second trace, number 5, mark our two functions, pressing enter. and we get x is equal to negative 1.5849625, yada yada yada, when y is 0. So we'll go ahead and round that to 1.58. And last but not least, let's look at letter D. It says change the equation so that the graph of the new function has no x-intercepts. So if we wanted to move this graph up, okay, remember right now it's always going to be right above negative 3. So if we wanted to take this and move it up so it was just always above the y-axis, I'm sorry, the x-axis, how far would we have to move it? So we'd have to move it up at least 3 units there. So let's see what that looks like. Let's take it and let's change our first equation here. If I add a value to this here, let's say let's add 3 to it. Oops, if I add 3 to it there, I should actually have plus 0, right? So let's just delete it off of there. And then graph it, let's see. Yep, it's always going to end up being above the y-axis there. So what we can end up saying here is that if we started out with y plus a is equal to 2 to the power of x. In fact, you know what, let's change that to k, because I think you're used to seeing it as k. So if we had y plus a k value of some sort here is equal to 2 to the power of x, what would this value have to be here? Our k would have to be, think about it, if we took it and we subtracted it from each side here and we had to have it over here, it's going to have to end up being less than or equal to 0. So let's think about that. If I put in there 0, right, we moved it over there, that would work. If I took it here and I said y plus negative 1, right, let's say y plus negative 1 is equal to 2 to the power of x. Well, if I took that down, I had to get rid of this minus 1. I'd add it to each side there, and I'd end up with y was equal to 2 to the power of x plus 1. So whatever this value of k is right here is always going to have to be less than or equal to 0, so that when we move it to the other side, it'll end up being positive. We want 0 or above on this side here. That was just an example so you could see it there. So this would be fine here as long as this k value was less than or equal to 0. All right, this is problem 5-63. Hopefully this helped you out if you had any questions. If you still have some, please make sure you ask your teacher. Thanks for listening.